Hi everybody, in this particular lesson we're going to talk about the differences between different kinds of t-tests so that you can identify which one is appropriate for what scenario and what particular research methods. So of course in any given t-test what we're doing is taking a continuous variable, obtaining a mean from that continuous variable, and then comparing that mean to something else. Now usually it is a mean of a different group on the same variable. In fact, it kind of has to be the same variable or we're not talking about a t-test. But there's some important considerations here about the research methods because uh, as we sort of talked about, an equation is stupid by itself. It doesn't know what research design you used. You're just pumping in data and it's giving you what it does, right? It's just kind of like a silly little computer that doesn't know any better about what you're putting into it. And so it's very important that we as researchers are almost hyper aware of what kind of T equation we should be using, what kind of test is appropriate for the type of data that we have. And so we're going to talk about the differences in the ways that you've obtained your data to figure out whether it's appropriate for a given kind of T equation. We haven't gone over any equations yet for the T, but we'll go over that, of course, shortly. Okay, so there are three types of t-tests broadly. The first one that we'll cover is the independent samples design. The second is the dependent samples design, or using dependent samples. And then the last one we'll cover is something called a one sample or sometimes a single sample t-test. So let's first talk about the independent samples design and what that means. So if you have an independent samples design, it's actually exactly what it sounds like. It means that the two groups that you're using don't have anything to do with each other except that they happen to be in the study together, right? So a really good question to ask yourself is there any reason to believe that one person in one of the groups has any influence on somebody else in the other group on this variable that we're talking about, on this dependent variable that we're talking about, okay? So, and if there isn't any reason to believe that, then you can probably treat them as independent samples. Now, sometimes you want them to be dependent on each other, and that's actually a very powerful design if you can design it that way. But sometimes it just depends on the question, and we can't really make it that way. And so we try to have them not dependent on one another. The important thing is you need to figure it out. If there's any reason to really think that they would be dependent on each other, that's important to note, and then of course use the appropriate equation. Now sometimes they are dependent on each other or independent of each other because they place themselves in the group themselves. They figured out their group membership on their own. Sometimes it was by random chance. Sometimes the researcher chose who goes in which group, right? You can randomly assign people to be in the experimental versus the control group, for example. Maybe God put them there. Maybe it was by just random chance. They happened to be there, right? It could be lots of things, and I'll talk about that kind of thing when I get to some examples here, and you can see. But here's maybe a little illustration that might be helpful. The main point here is this little guy, right? Is that right here in the middle that there's no influence. So, for example, if I have students from college A, it could be any college, and students from college B, and maybe I'm curious, do they differ in IQ on average? Well, do I have a reason to believe that they're influencing each other's IQ? And probably not. It seems, I mean, it would kind of depend, right? So here's maybe one way to think about that. Um, how close are these colleges to each other? Are they in the same city, for example? If they're in the same city, is it possible that some of the students who go to college B used to go to college A? You would probably want to check that out as a researcher and see if that's something that's occurring. Is it also possible that that students are roommates together, and therefore they probably are kind of influencing each other's IQs in subtle ways, maybe, or it was something about each other that brought them together in the first place to be roommates? So those would be the kind of questions you'd want to check out. And if you can, exclude people who do seem to be influencing each other's scores, unless that's the point, okay? So unless you want a dependent samples design, probably you want to avoid any kind of appearance of dependency. Okay, so that's one way of looking at independent samples. Now, dependent samples, of course, are the opposite of that. That's where you actually do, in many cases, want people from group A to influence people from group B. I'll talk about some of the reasons why that would be here in just a second. So there are lots of ways that you can do this, at least two major ways, and then there's some variations of those that I won't get into. But The most common and probably one of the most powerful kind of t-test is a repeated measures design. What that means is that you have the same population or the same sample of people, you test them once, then you do some kind of intervention. Maybe you educate them, you have them take a class, you give them a drug or something. Then you test them later. It's the same people. And the point is, you of course want to measure the influence of whatever your intervention was. So it's a very powerful design to test them before the intervention, then test them after the intervention. And what you essentially can tell is what was the effect of that intervention on whatever your variable was. So one excellent little example of that would be, let's say that somebody comes into my my classroom and they say, hey, I need some help with stats. And I say, hey, really quickly, how about you complete this little survey really quickly to see how you're doing on stats? And they do that. And then I say, okay, now we're going to do our tutoring session. After our tutoring session, I give them the same problems and I say, okay, now fill that out and let's see how you did. And if they showed a major improvement, I can assume it's because of my stats tutoring, for example, why they had that improvement, right? It's the same person in that group. So again, a little illustration. This is supposed to be the same person both times, and just I test them once before the intervention and once after. That would be an excellent example of a repeated measures design. However, there are some other kinds of designs that are similar to that in some ways. For example, a matched or paired samples design. Sometimes you could do this where you have people who are not the same person in two different groups because it just wouldn't work to do that. Like let's say you want to do a cancer treatment, right? And let's say you have two different people, and so you can't do both. Well, I mean, in some cases you could do both cancer treatments at different times, but you might not have that ability, or you might not be able to sort of flush out the effects of one treatment upon another. And so you might get people who are very similar to each other in every other way, or at least hopefully every other conceivable way. You give one of them one of the treatments and one the other treatment, but you essentially pair them together, and you say, okay, now Steve, you're very similar to John, so we're going to consider you two, similar to each other. And now we're going to compare Steve's cancer or whatever to John's cancer, for example. So that'd be matched or paired samples. Now, the best way to do this is if you have identical twins and you treat them both differently, right? You give one twin nothing maybe, and the other twin some kind of treatment, or you could give them different treatments and then you see how they differ from each other. So anyway, and then there are of course some other variations of things like that. So that's called a matched or paired samples test. It's one of the examples of a dependent samples design. Now the last one we'll talk about with a t-test, of course, is called a single sample, or sometimes a one sample t-test. Now this is an interesting one because you as a researcher gather data from only one sample, and then what you do is compare the data from that sample, specifically the mean, to some criterion that you set. And it could actually be anything you want, but you would want to have it informed by research probably. So really good example here might be something like this. Let's say that I wonder if Chicagoans differ in their IQ from the rest of the population, right? Now, I don't need to collect a different sample of the world and find out what their IQ is because I already know this. This has been established. This was purposely set that the mean IQ is 100 and the standard deviation is 15, right? So it doesn't make any sense for me to waste my time and resources to try to figure out what's the average IQ in the world. So what I could do is just get a sample of Chicagoans and test their IQ against the measure of 100, against that average of 100, and then the single sample test can tell me whether it was different, right? Statistically significantly different. Or you could also set it to really any criterion that you want. Like for example, I've done this in my own personal research. In my dissertation, for example, I wanted to see if well, this is a little bit different, but I wanted to see if therapists' practice time had been different, or their administrative work had been different time amounts than what a researcher had done several years before. And so I didn't have their standard deviations. I didn't have a lot of their information. I just knew that it was 6 in that original study or whatever. And so I said, is it different from 6 now in this 15-year later study? And that was a single sample t-test. I think it was actually different, if I recall. But anyway, you can read my dissertation if you're interested in that. Just email me or message me. Okay, yeah, so this is a nice little illustration of what that can look like is you just get a single sample, the researcher gets one sample and compares their mean, whatever their information is, to some criterion that you set as a researcher. And it can be the national average, it can be data that you have, compared to data that you have from some kind of national database or something like that. All right, real quick practice. Let's see how we did. So I'm going to give you some scenarios, pause the video and think for a minute, and then I'll explain what I'm thinking about this. Okay, in the first one, you survey people in an apartment building, grouping them by first or second floor, and then you ask them about the temperatures in their apartments. So what you're trying to see is, do their temperatures differ in their apartments? Okay, my take on this is you probably would call this a dependent samples design if you wanted to be very cautious about this, because do you have any reason to believe that somebody's temperature on the second floor, for example, depends on the temperature in the first floor? And the answer is, well, probably, yeah. I mean, unless it's very good insulation, we know hot air rises. And so there's actually some reason to believe that somebody on the second floor's temperature of their apartment would depend on the person below them. So you do make this a matched or paired samples design, and you would have people matched up by who's right above them and who's right below. They would be paired together, and then the people above would be compared to the people below. Something like that. That seems like the most logical one. Okay, here's the second one. I test my forensic psychology students about their ability to profile a criminal at the beginning of the semester. Then I test them again, the same class, at the end of the semester to see how much they improved. That's a perfect example of a paired samples test, right? Or a repeated measures design, okay? It's the same people just tested at different time points to see if they improved on that dependent variable, which in this case would be their ability to profile a criminal. So that's a dependent samples design for sure. Let's say I examine depression differences between Catholics and Protestants. Now, most likely here, this would be an independent samples design because you would ask yourself, do Catholics have any influence on the depression levels of Protestants or vice versa? And there's not really an obvious reason to think that there would be. Now, a couple of things you would want to test for example, let's say that you have a married couple and one of them is Catholic and one of them is Protestant. Well, we should probably separate them or exclude them from our study because there is reason to believe that if you have a shared environment, that there might be something going on there, right? So I might want to just control for that and be careful with that in my research methods. But otherwise, there's probably not really any reason to believe that there's something going on. Or additionally, like roommates, are they one's Catholic, one's Protestant, and they're roommates? Things like that. We would want to be careful about that. Another one, I test whether ovulating women's core body temperatures differ significantly from the average body temperature of 98.6, which of course everybody knows is average. Now, obviously here I'm collecting only one sample of ovulating women, and I'm comparing them to a criterion that is already established, something I already know. So this is clearly a single sample t-test. Another one might be comparing the longevity of smokers to non-smokers. Now, this is probably independent samples, but again, a few things you would want to test because let's say that you have a household where one person is a chronic smoker and another person doesn't smoke at all. Well, because they share the environment, now how much one person smokes actually does influence somebody else and how much they smoke, right? And specifically, probably their longevity. In fact, there's pretty good research that secondhand smoke is devastating to your health. So unless they're sharing an environment, I would probably treat this as independent. However, I would be very careful about sources of secondhand smoke for the so-called non-smokers, right? So independent samples most likely. And we'll do one more, understanding sex differences in vocabulary, okay? So in other words, you're taking males and females and testing their vocabulary levels. So again, the question here is there any reason to believe that a female's vocabulary would influence a male's vocabulary or vice versa? And again, probably independent samples, unless of course you have reason to believe there's a shared environment. If you had siblings, for example, that were in the same household, you had a male sibling with a female sibling, they have the same shared environment. Probably their parents are influencing their vocabulary generally. So I wouldn't call them independent from each other. But if you're getting them from different locations, different households, for example, probably good reason to believe that those would be independent. All right, now naturally there are lots of different other scenarios here, so practice with this. This does take some time and effort to really get to understand. Okay, a quick wrap up of what we talked about. So a statistical test's appropriateness really depends on how the research was put together, how the design was made. And so sometimes, in fact, a good researcher should have this all planned out very carefully before they start gathering data. So that's a really important thing to consider. And then in mean comparisons, the major thing that we're usually interested in is, are the samples dependent on each other or are they independent? And of course, in some cases, also you use only a single sample. Those are hopefully a little more obvious than the others, however. Okay, so if they do depend on each other, we call it a dependent samples test, and then the actual design will depend on some other things, like if it's the same population or just matched, for example, but the equation would be the same. And then an independent samples is better if you have no real reason to believe that they would influence one another. And which is appropriate for your design just depends on what it is you're going for. So it's the kind of thing you'll need to talk to some expert about and see if that's what you're going for if you're not sure yourself. And then there are some cases where you have only one sample, and so you want to take their data and compare it to a single criterion. That is called a one sample test. All right, next we'll get into more information about the t-test, and we'll eventually work our way up to the actual equation. I will see you then.